About a month ago, I saw a video on Reddit where one of these "which cup gets full first" IQ puzzles is being simulated. I really liked the concept and wanted to make my own program, which could take some sort of image as input and output a video. But first, which language should I even use? My first thought was JavaScript in the browser, since you can easily create an HTML canvas and draw to it from JavaScript, but importing and exporting is difficult and you have the problem of performance. I also thought of Python, but I know from experience that it's unreliable and working with mutable arrays is a pain. So in the end, I want to Rust. It's very reliable, performant, has no unexpected behavior, and has a good module system for dependency. One drawback is that it compiles into an executable and doesn't run in the browser, but the other features are worth it. The first question to ask is, what should the program even do? Well, first, it should load the image as a 2D array, and then what? Let's start by imagining an example. We should have three types of cells: air, water, and wall. And there should be one pre-existing cell of water where it originates from. Let's think about what we think should happen. First, the water runs down by duplicating. After the water can no longer go down, it goes to the sides. And when it can't even go that way, it goes up. When it finds a place where it can go to the side, it goes there, and this goes on. Notice that the water prefers to first try to go down, then to the side, and only then up. Also, notice that only the lowest cell that can move moves. So how do we compute the flow of this simplistic water? Every frame, we could scan all rows from bottom to top and look for water that can move in any direction. When such a row is found, try to first move all water cells down. If no cell can move down, try to move all water cells to the sides. If no water cell can move to the side, try to move all water cells up, at which point it's guaranteed that at least one cell can. One improvement in performance can be made. Cache the y-coordinate of the lowest movable water cell, so you will be able to start scanning at that y-coordinate -1, since water can't move more than one cell down per frame. We still need to somehow export everything as a video. For that, we can save every frame as an image to the images directory and at the end combine them into a video using FFmpeg. It would be ideal to save the images on a separate thread, since both computing frames and saving images are intensive tasks. Let's get to coding. After creating a project, I want to be able to parse the command line arguments so the user can specify the image path, frame rate, etc. For that, I create an args structure, which derives the clap parser trait. It is also a very good idea to use a logging library, like log and environment logger, to get colored logs and differentiate between infos and warnings. I also created a cell enum to store the different states of a cell: wall, water, and air. The cell enum also implements the fromPixel function to easily transform an RGB value into a cell. In the main function, I load the image and create the images directory. Then a thread scope is being initiated. It is used to automatically join all threads at the end. Inside, the cache max y variable is created, which is used for the optimization we talked about earlier. After that, there's a frames for loop, inside which is another for loop which iterates over all rows on the image. First, all water coordinates in that row are being found. If there's space below the water cells, the water will be moved and the next frame begins. This repeats for movement to the sides and to the top. On the end of each frame, a thread is created to save the image of that frame. When no single cell in the entire image can move, the frame loop breaks and FFmpeg is executed to combine the images into a single video. Let's run it and have some fun. If you want to experiment by yourself, click the GitHub link in the description and follow the installation guide. Please drop a like and see you soon.
you.